Hello and welcome to Security. This is a continuation of the Cyber Defense Tryhackme Pathway project, and in the previous video I covered introductory networking. If you've not seen that video, I'll put the link right now where you can go see it. And in this video I'm going to be covering network services and network services 2. So without further ado, let me just get right into it. Okay, so if you read this, it says get connected. This room will explore network service vulnerabilities and misconfigurations. But in order to do that, we need to do a few things first. You have to have a basic knowledge of Linux, and you have to connect to the Tryhackme Open Vpn access. So yeah, if you've not completed the Linux fundamentals, you can follow this link and go complete it. And yeah, basically I've done that. So yeah, there's also talks about how this is not about Wi-Fi hacking, and if you're interested in Wi-Fi hacking, you can follow this link to see what it is, or to see more on that. So if you have all the requirements, let's get into the room. So here it talks about SMB, and the answers to these questions, basically you can find them by reading this. And so it talks about enumerating SMB. To do that, we need to launch a machine. So I'm just going to give a couple of minutes for the machine to be launched. Okay, so now I have the machine up. I'm just going to connect to the Open VPN environment. So I go to the folder where I have my Open VPN key file, and I connect. So now I'm connected to the Tryhackme environment. So I can split my terminal and start working, basically. Okay. So task 3, you can read through this, and it talks about enumeration. It's a process of gathering information in the client in order to find a potential attack vectors and aid in exploitation. So here we're going to be enumerating the system, basically using the SMB service. So the first thing we're going to do is conduct an nmap scan on the target to see how many ports are open. So I'm just going to run an nmap scan and put in the IP address of our target. So basically this scan simply just shows us the ports that are open on our target. So it says what number of ports are open. You can see we have 4 ports returned, but 1 is filtered and 3 are open. So we have 3 ports open on the machine. So it says what ports is SMB running on. In order to do that, we have to get a little bit more information than just the ports that are open. So we'll probably have to run another nmap scan. So what I'm just going to do is run this scan that basically run the default script to give you more information basically on each port that's found open on the target. So now we have the results for our search, and you can see on port 22 we have SSH running, and ports 139 doesn't really say much, but on port 445 we see SMB is running. So for sure we see SMB is running on port 445, but usually SMB runs on port 139 and 445, and we can just confirm that by searching the SMB default ports, and you can see like it runs on 139 and 445 by default. So since we have just three ports open, the answer for this question should be 139 and 445. So it says let's get started with enum for Linux. Conduct a full basic enumeration. For starters, what is the workgroup name? So if you come up here and you read the basically the information that's here, you see how to use enum for Linux. So you just basically use the command option and the IP address of your target. So for a full basic enumeration, we're going to use the A tag. And so basically we pull up our terminal, type in enum for Linux, put in our tag and the IP address of our victim or our target. So just give it a couple of minutes to run. Okay, so now we're done with the enumeration, and what we could be expecting basically from this results is, you see here it says all of the above. So we're expecting all these things from the result that we just got. So we can get the user list, machine list, name list dump, share list, and password policy information, as well as group and member list. So now we can go basically look through results. So it says what comes up as the name. First of all, what is the workgroup name? So let's pull up this one more time. So we can go to the top basically for the results, and we can see the workgroup name is workgroup, and what is the name of the machine? So here we can see the server. It gives it this name, follow SMB, and OS version is 6.1 for the next question. So the next question says, what share sticks out as something we might want to investigate? So what share sticks out as something we might want to investigate? So we can pull up our terminal one more time and look for the shares. You can see the different shares, and yeah, basically investigating the user profiles share will be, for example, if a black hat basically gets, or a hacker gets access to a computer, that's something that will be interesting for the hacker to investigate, because that can help with getting privileged access or more prolonged access to the system. So now we'll go to the next task, which is exploiting SMB. So it says, while there are vulnerabilities that allow remote code execution by exploiting SMB, you're more likely to encounter a situation where the best way into a system is due to misconfigurations in the system. In this case, we are going to be exploiting the anonymous SMB share access, a common misconfiguration that can allow us to gain information that will lead to a shell. Okay, so you can continue reading through in order to understand, and for that we're going to be using the SMB client. And so it says, what will be the correct syntax to access an SMB share called secrets as user suite on a machine with the IP 10.10.10.2 on the default port. So if you read this, if you read that, you see that this is going to be the answer for that. So next it says, let's see if our interesting share has been configured to allow anonymous access. That is, it doesn't require authentication to view the files. We can do this easily by using the username anonymous, connecting to the shell we found, and not supplying a password. So pull up our terminal again. So what we are going to do is try to connect to this share, the profile share, with not supplying any username or password. Okay, so SMB client is our command, and we are going to specify IP address of our target. That's 40.149, and then specify our share, which is profiles, and we just specify the username first of all as anonymous, specify our ports as 445. So it says enter workbook password. We say no, we don't put any password, and say we're connected, which means it allows for anonymous access. So it says now have a look around for any interesting documents that contain valuable information. Who can we assume this profile folder belongs to? So let's see an ls here. Okay, now we can see an interesting file, working from home information.txt. So all we're going to do is we're going to copy this file to our system so we can open it and basically see what is inside. So let's see. Let's get the file. So because basically there are spaces, you have to put them into quotes in order for it to work properly. Okay, so now we have the file back on our system. I can exit ls, and I can read this file. Let me see, a nano. Okay, so now we are in the file. We can see it is addressed to someone called John Cactus. So I think we can assume, it says who can we assume this profile folder belongs to? We can assume that it belongs to John Cactus. So it says, as you're well aware, due to the current pandemic, most of Polo Inc. has, let me extend this a bit. So most of Polo Inc. has insisted that wherever possible, employees should work from home. As such, your account has now been enabled with SSH access to the main server. If there are any problems, please contact the IT department at this IP address. Regards, James, Department Manager. So what service has been configured to allow him work from home? We can say it's the SSH. So we'll exit and reconnect to our SMB client. It says what directory should we look in? If we ls again, we can see this .ssh folder, and we can basically say yes, let's look into that folder. So I pull up my terminal one more time, and now I'm going to cd into the .ssh folder, and if I ls, I can see basically the SSH keys for this John Cactus person. So what I'm going to do is download the key file. This is the private key file for John Cactus, the ID RSA. So I'm just going to download it by doing a get, and now it's sent to my local system. So now I can exit because I have what I need. And so I have the ID RSA file. It says download this file. Okay, alright, that says change permission to 600 using this command, chmod. So I did that as well. 600 and the ID RC. So that is done. Okay, so it says now use the information you already gathered to work out the username of the account. Then use the service and key to log into the server. So one way we can get the username should be from the public key file. And if you remember, when we connected to the SMB, to the server using the SMB client, and we go into the SSH folder, there's a public key file here. So we can also get the public key file. Now if we go back to our local machine and rather just cut it, the public key file, you can see cactus at Polo SMB, which is our server. So we can see the username at our server. So now we can that should be the username of John Cactus, basically. So now we can SSH into the folder or the server as John Cactus. So how do we go about that? We SSH, we specify our key file, which is our ID RSA, and we're going as Cactus into our target server. Yes, and just like that, we are into the server. So for ls, you can see this smb.txt file. Basically, read the information, we get our flag. So that's the end of our exploiting SMB part of this room. So now I can terminate this machine. So the next task is understanding Telnet, task 5. And yeah, you can just read through this information. But basically, Telnet is a very service that allows you to connect remotely to a machine, and usually it's done over clear text. So Telnet is basically, it's not the recommendation or the recommended standard to connect remotely to machines. SSH is recommended because SSH is encrypted, while Telnet is not. So yeah, basically you can read through and answer those questions, but we can go through the practical part together. So I'm just going to start the machine and give it a second to start up. Okay, so now the machine is up. We can start with enumeration. So pull up a terminal, and it says how many ports are open on the target machine. You can do a regular nmap. If you do a regular nmap, what I found out was that because this machine is not the regular nmap basically scans the well-known ports, which is from 1 to 1024. But if you want to, if none of those ports are open, a regular nmap scan will give you no result. But if you use this flag that specifies that you need the nmap scan to go beyond the regular well-known ports into and scan all the ports rather, then you get a result in a situation where the well-known ports are not being used. So now I'm just going to specify our target, and I give it a second to scan. This might take a bit of time. Okay, so the nmap scan is done, and yeah, this takes a long time because it's scanning every single port in the 1 to 65,000 range. And yeah, so we can see that one port is open, and that's the answer to the first question. What port it is? It's 8012, and the port is unassigned but still lists the protocol. What protocol is this? You can see the protocol is TCP. So it says we run the nmap scan without the p tag, and how many ports are shown as open. So like I said, when you run the scan without the p tag, this tag is going to basically scan for only the well-known ports. So when I run this, it's not going to give any result. Basically, it's going to show 0 ports are open. So I'm just going to give it a few seconds. Okay, so here, correction of something I said earlier. Basically, the ports that are scanned with the regular nmap scan are not just the well-known ports, but like common ports basically. So there's some services that use ports even beyond the 1024 range, but they are common ports. So nmap scans those ports as well. So basically, you can see from this, what we can see here is the nmap scan returns the list of these ports, and all of them are in the state filtered. So no port is open basically. And if you're running an irregular nmap scan without the p tag, let's say you're an attacker, for example, you'll think there's no open port on the machine, but there actually is an open port, but not just using a standard port. And that's what's being explained here. So it says, based on the title returned to us, what do you think this port could be used for? Title returned to us. I think what we can do there in that case is to connect to the ports. And because if we just use the telnet command and the IP address, it's not going to work because telnet by default uses the port 23. So it's not going to connect. So we have to specify this port that we found, that this telnet is using specifically on this host. So when we telnet into it, we can see skid backdoor. So I can say, based on the title written to us, what this port is for. The answer should be a backdoor. And what could it be? What could it belong? Who could it belong to? So here we can see Skiddy's backdoor. So they can guess that this backdoor belongs to Skiddy. And yeah, so that's the end of the task on enumerating telnet. And the next task is exploiting telnet. So here it talks about different types of exploit for telnet and how you can get a reverse shell as well. You can read through the notes basically. So it says, okay, let's try and connect to this telnet. But if you get stuck, have a look at the syntax for connecting the outlined above. So it says it's an open connection. Great, it's an open connection. What welcome message did you get? And you can see basically when we connected to the telnet, what we got was the Skiddy's backdoor. So it says try executing some command. Did we get any return? So let's say we ls. No, we can't get any print closing or working directory. No, we can't get any return on any input we enter into the telnet section. So it says that's strange. Let's check to see if what we're typing is being executed as a system command. It says these steps, basically we can follow these steps. Start this TCP dump listener on your local machine. If using your own machine with the Open VPN connection, use this. And if using attack box, use this. So basically, if you're using the attack box, you use this. But since I'm using the Open VPN, I can use this. So what I do is basically split this terminal vertically and paste this command and start this. Okay, so now it starts a TCP dump listener, specifically listening for ICMP traffic which pings operate on. Okay, so now we use the command ping. This will be the IP address of your Tryhackme interface. So you type in this command, replace this part with the IP address of your local Tryhackme interface through the terminal session, and see if we're able to execute system commands. So what we'll do here is basically right here. So first thing what I can do is I can split my terminal horizontally here and do an ifconfig to get the IP address of my Tryhackme interface. So this is a tunnel 0 interface, which is being used by Open Vpn to connect me to the Tryhackme environment, and the interface IP address there is 10.6.73.10. So I can collapse this subterminal. So basically it says preface the command with .run. So what I can do is do a .run, and I can type in the command ping, and the IP address was 10.6.73.10, and with a count of 1, and I run it. Just gonna try that again. It says .run, so I think that should be capital letters. And try it one more time. 10.6.73.10. I'll run it. You can see we got a response. ICMP echo request. This is coming from the IP address of our target, which is the same IP address right here. So the answer for that is yes. So it means great. This means we're able to execute system commands, and that we're able to reach our local machine. So now let's have some fun. So basically, what we're going to do is create a reverse shell and find a way to execute it on the target machine, so that it creates a shell, a reverse shell connection basically to our local machine, and we can basically interact with the target machine through the shell. So it says basically run this command to create the reverse shell. You can just copy it. I can stop this and paste to create. Oh, yeah, I need to change this to the IP address, the IP address of our Tryhackme interface, and then we can run this. Give it a couple of seconds. So it says, what does the payload start with? And the payload starts with MKFIFO. So now it says perfect. We are nearly there. All we need to do is start a netcat listener on our local machine. So we can listen on the port 4444, which is the port we created this reverse shell to run on. So what we can do here is run a netcat listener, and this is the L is to put it in the listening mode, V for verbose, and P to specify the port, which is 4444. So now we are listening on port 444 on our local host, and so basically this is the command. So listen on that port. So it says great now that's running. We need to copy and paste our MSF Venom payload into the telnet session, and run it as a command. So this is our payload. We copy it, type our dot. So we go back to our telnet session and dot run and paste our payload. So run this, and we have our reverse shell. So this should have given us a command, a connection to our target. So let's do an ls, and we can see our flag. I'm going to read the flag .txt. We get our flag. So say success, what is the content of the flag? Just copy that and paste it in, and that is the answer. And that's the end of the task 7, which is exploiting telnet. So now we're done with this telnet machine. We can terminate it and move on to the next task, which is understanding FTP. Okay, so task 8 says it's about FTP, and FTP, as the name suggests, is a protocol used to allow remote transfer of files over a network. So basically, you can read this for task 8. You just have to read through this and answer the questions. So we'll go to task 9, which is enumerating FTP. And for that, we need to start the machine. Just refresh the page quickly. Okay, so I'll start the machine now, and I'll give it a couple of minutes to start up. Okay, so now we're back, and the question it says is first question is run an nmap scan of your choice. How many ports are open on the target machine? So you can just run a basic nmap scan to our target, which is 10.10.88.198. If you give it a few seconds, we can see 2 ports are open, port 21 FTP and port 80 HTTP. It says what port is FTP running on. Clearly we can see it's 21. And what variant of FTP is running on next. So pull up our terminal. In order to know what variant of FTP is running, you have to use the tag SV like this, and this basically gives the version of your service that's running on a port in the scan. So we give this a couple of seconds again to run. So we can see FTP. We have VS FTPD running for as our FTP version, and Apache as our HTTP version. So what variant of FTP is running on the answer is VS FTPD. So great. Now we know what type of server we're dealing with. We can check to see if we're able to log in anonymously to the server. We can do this by typing FTP, the IP address, into the console and entering the anonymous and no password when prompted. So what's the name of the anonymous FTP directory? So let's connect to our host using the FTP and the IP address, which is 10.10.88.198. So it says what is the username. So let's use anonymous as our username, and our password, no password. And here we're successful. So it says what's the name of the file in the anonymous FTP directory. So let's ls, and you can see the name of the file is publicnotice.txt. So what do you think a possible username could be? Could we let's read through this? It says, okay, so we can try reading this public notice file to see if we can get that. So cat doesn't work. Let's see. Type see, commands are available, so we can get it. So now we can exit. Unless we can open up public notice.txt. So, message from system administrators. Hello, I hope everyone is aware that the FTP server will not be available over the weekend. We will be carrying out routine system maintenance. Backups will be made to my account, so I recommend encrypting any sensitive data. Cheers, Mike. So we can try Mike as the possible username. And great, now we've got details about FTP server and crucially a possible username. Let's see what we can do with that. So that's the end of task 9. And now we're going to task 10, which is exploiting FTP. So here, talk about types of FTP exploit. You can read through the note, but basically we're going to be using Hydra to try and brute force the password of this FTP username. So we're going to use this command, and we're going to specify a word list. And if you don't have the word list on your local system, you can download it. You can just search online for rockq.txt word list, and you'll be able to download it from GitHub. Oh, to try here, the link to it. Okay, there's the link to Hydra, or you can also search for rockq, and you'll be able to get the word list online. Okay, so now we can answer the questions. What is the password for user Mike? Let's just copy this password, or this command rather. I think I have the rockq.txt file somewhere. I need to confirm. I think I might have it in that same directory. Let me paste it in the command first of all. Do I have the word with rockq? Oh yes, I have it in that directory. So now we replace this IP address with the IP address of your target, and the username is Mike. So run it and give it a couple of minutes, and you can see we already got the password as password. So now let's connect to the FTP using this user as the username and the password as the password. So we're going to rerun this command FTP, and now our username is Mike and our password is password. Give it a couple of seconds. So I have to retry that. Username is Mike and the password is password. So now we can see login successful, and when we list, we can see 2 different files. It says what is ftp.txt. What is ftp.txt? You Can we get it? Get a vp.txt. Okay, so let me see. So we have the flag in it. Okay. Okay, so yeah, that's the end of this network services room. Basically, this is some options for further learning, but generally I hope this has been helpful to someone, and yeah, I'll see you in the next video. Thanks for watching.